So in the last class what we did was we understood how we could use Keras to solve a very simple problem. What was the problem? The problem was the MNIST dataset. So what exactly was the dataset again? There were handwritten numbers, images of handwritten numbers, and we had to identify what number was written here. So that was the whole task. So what we did was first we loaded the whole dataset and then we created a model, the architecture of the model. We also showed how we could use the summary function and plot model function to actually understand more about the whole model architecture. Then we compiled the model and we fit the model, right? We saw during the epochs how things kept on changing, how we changed the loss and everything, and accuracy kept increasing. Then what we did is we saved the model. So why did we save the model? This is because every time we don't want to train the model again and again. So what will happen if we save the model is this model can be loaded again and we could use the same model without training. But there were some other parts that I did not show you. Like for example, there was this history. So what is history is basically this model.fit. This is saved in a variable known as history. Now history itself has history. So we can see here, this is the history. So these are the different losses, and these losses are from say the first epoch, and this keeps on decreasing till the final epoch. Same way we have accuracy, this is for the first epoch, and here you have the final epoch. The same way we have validation loss and validation accuracy. So this is how we save the history variable. Okay, so what we can do is we can plot the losses and validation loss. So why do we do this? So if you might have remembered, this is usually done to check whether our model is underperforming or overperforming. So that means whether it is overfitting or underfitting. So here you can see, since the validation loss and the train loss, the graphs are very close to each other, that means it is neither underperforming nor overperforming. The same way we can plot the accuracy. So we have training accuracy and validation accuracy, and you can see here this here is very close to each other. That means this is neither a very great big loss nor is it a very small loss. Okay, then we have this load model function. Now we have saved the model, right? But we also need to load it. So this is why we have the load model function. So our model gets loaded here. Let us run and see how well our model is performing. So here what I am doing is I am using one value from xtext. So this is the 0th value. So let us see what this looks like. This is a number 7. So what you need to understand is we are using plt.imshow. So why is it that we are using imshow and not plot? So one thing also that you need to understand is when you are using, let's say, a plot function. So what happens with plot is it uses graphs to draw. So if you are using plot, that means it will plot the graphs. But we do not want it to plot the graphs. We want it to show the image. So that is why we will be using imshow. Okay. Now first what we do is we reshape the xtest value. So why are we doing that? Let us first see what the shape of xtest is, right? You can see here the shape is 28, 28. Because this is 28 pixels, this is 28 pixels. But we cannot feed this in this shape. So why is that? If you remember the architecture here, we had an input which was question mark, 28, 28. So this was the shape in which the model was trained. So this is the shape where it will take the inputs also for prediction. So that means if you are predicting, you have to change the shape to this. So obviously the question mark was for batch, but here we are testing on one data. So that is why this question mark changes to 1 here, because the batch size is 1. Okay, now let us run this. See, it predicts 7. And we are using np.argmax. So why is that? If we just do model.predict, what it will show here is these results. So again, if you remember the output was question mark comma 10. We know the question mark is 1, but it will give us 10 outputs. Why is that? So it will give us the probability for each number, so that each number can happen. So probability that this number, this image is 0, this is the probability. The probability the number is 1, this is the probability, and so on. So out of all this, the highest probability is for number 7 here. You can see to the power 1 minus 1, so that means you will shift a dot here. So the probability that this image is a number 7 is 0.95. Okay, cool. Now what are the few things that could have been done? Like you can see here, the accuracy did not increase by a lot, so the final accuracy was around 0.84. If you remember, in the last class I mentioned the reason why accuracy did not increase was because this is a 2D structure. So you have 128 pixels here and 128 pixels here. What we are doing is we are converting it into a 1D. So this 1D is not utilizing the dimension that the image has, the 2 dimension, which adds an extra let's say a layer or an extra dimension to it. We are not using that. So that is why one reason is that we ended here, and the other could be we are only running this for 20 epochs. So if we increase the number of epochs, there is a very high probability that we will get way more accuracy, right? So what you can do is you can try running this for, let's say, 25 epochs, 30 epochs, and then you can plot it out and see whether you are overfitting or underfitting, right? Okay, so there is one more thing that I wanted to show you. This is a Colab notebook. So what exactly is a Colab notebook? So a Colab notebook is the same as a Jupyter notebook. But Colab is provided by Google. So why am I mentioning about Colab? So the reason why I am mentioning about Colab is there are a lot of things that you can use in Colab that you cannot use in your normal PC. Let's for example say you have this option here. Other options are like mostly the same as you can find in your normal Jupyter notebook. You have located, like there are a few things I will explain obviously, but most things are the same, like select cells, cut, copy, paste, then there are views and everything. But the interesting thing here that you don't have here is this runtime option. So what runtime does is basically, if you say run all, obviously it will run everything, run before and everything. Interrupt execution, well, a cell is running and you want to interrupt it, you can do that. Restart runtime. So whenever you open the Colab notebook, you have a runtime here. Alright. So what you can do is you can actually terminate the runtime here through this option. So what this will do is if you are using it, it will stop. So it shows the RAM used and the last execution. So this is a new notebook, so there is no execution. So you have runtime. The other interesting thing about this is change runtime type. So this is an hardware accelerator. So what that means is you can change this runtime here to GPU or TPU. So presently it only uses the CPU option. But since GPUs are very costly, you can actually use the Colab notebook for, let's say, 8 hours or something so Colab gives us a quota. So every week there is this amount of hours that you can use the free GPU. But then there is also an option, I don't have it here, but there is an option of Colab Pro. In that case, what will happen is you can increase that quota time. Okay. So let us understand the differences between CPU versus GPU, and there is this very new thing called TPU. So What CPU is central processing unit, obviously. GPU is graphic processor unit, and TPU is tensor processing unit. CPU is mostly in your built-in laptops and computers and personal use things, and it is basically used. You might have heard of all these units in the CPU itself: arithmetical logic unit, control unit, memory unit. So it is used to perform all the logical and arithmetical operations, as well as it is used to control and manage the systems and happenings and everything in the CPU. A CPU has 1 to 8 cores. Now let us talk about the GPU. So GPU is basically used for all the graphical things. It is used for DSP calculations. So all the graphical things, by that I mean, let's say video editing and stuff, it can be used a lot. Obviously you might have heard of graphics card, that is basically the GPU. And other than that, GPU has more than or around hundreds of cores. So why this core thing is important, I will mention. But here we have then TPU. So TPU is basically a distributed GPU. This is like the fastest if you are using for any deep learning running. You might have heard that sometimes model takes a lot of time. So this was a very small MNIST data set. So here what happened is it did not take a lot of time. It took like 3 seconds for each epoch. So if you multiply that by 20, it is what, 60 seconds. But again, this is a small data set. If you increase the data set, increase the number of epochs, it is going to increase. The size is going to be massive. So what happens is sometimes you have like training that goes on for 3 hours, 4 hours, 5 hours. So in that case we require a distributed GPU. What distributed GPU basically does is, let's say it has a lot of GPUs. So what will happen is you put the data here somewhere, it will distribute it among all the cores. Then again it has many cores, more than GPU. The interesting thing about TPU is this is basically just for tensor related stuff. So hence you can understand the name TensorFlow also. So it is just for tensor related stuff, for deep learning and everything. GPU you can do a lot of other things also. So that is why it is not totally built on TensorFlow or just for TensorFlow. TPU is provided by the cloud, by Google. So you can find TPU only through Google. They charge like what, $450 per hour, as far as I remember. Okay, so TPU, so now what happens with the distributed unit is, and why we use GPUs and CPU and TPUs more than GPU is, they increase the training time. So I have seen programs or I have seen models that run on GPUs for 5 hours, 6 hours. So if that is turned into, well, let's say a CPU thing, this will increase by a massive amount. It can happen that this can run for, let's say, 23-24 hours. So that is why people prefer GPUs. It has more number of cores, so we can actually distribute the training to each and every core. So we don't have to worry about all that distribution techniques, because the good thing about Colab is it does that on its own. So now there are a few other things in Colab. You have here where you can manage sessions and check the amount of RAM used. Obviously you have here this folder. Okay, this is used to mount the Google Drive. Since okay, so this is how you mount the Google Drive. Now what exactly does that mean is, suppose you have some data set. Now if you want to run the data set directly here, you cannot do it. I mean, you have suppose this data set, so you can save the data in your local directory, right? But in this case what you do is you cannot do that. So you can connect it with your drive. You can upload stuff into your drive, all the, let's say, CSV files and stuff like that, whatever data you have, and then you can connect to your drive. Now if I do, let's say, pwd, so it says content. So all my drive things will be saved in this my drive option. So what I can do is, let's say, copy the path and then I can go into the path. So now I am inside here, and now I can run everything. All the data is in this part, so we can use all the data here. So this is basically Google Colab. So since GPUs are very costly, what Colab does is it provides the whole GPU thing but for free. So obviously there is some quota, but it's like pretty accurate, and you can also use TPUs if your data is like very large. But what happens is most of the time people prefer GPUs because they usually don't have such large data, and if they do, they usually prefer cloud services to this. So that is about that is everything about so that is everything about the Google Colab part, and we also went through the last part here. In the next classes, what we will do is we will understand more about TensorFlow. So TensorFlow itself has two parts, TensorFlow 2 and 1, and we will go through each of that very quickly and we'll understand the basics, and then we'll also talk about the reasons why TensorFlow should still be known and we should still use TensorFlow. Okay, that's it. Thank you and enjoy your learning.